Now let's take a look at the smart meters evolution. At present time, the high voltage users have been converted to smart meters, and household and the low voltage users have gradually converted, helping us to progress from the manual meter reading in the past communication meter reading system. And you can see at the right side, from the mechanical meter to the electrical meter to the AMI nowadays. Because of the user of the smart systems, we can apply dynamic electricity pricing to the users and display the information in real time on the web page and applications on your mobile phone. Smart meters can also monitor, control, and report various events back to the operator. Electricity and the related data collection. Popularization of smart meters is the very first stage of the infrastructure of smart grids. Smart meters are not enough. Whether the network connection can be smoothly transmitted, whether the delay is low enough, and whether the bandwidth is sufficient to meet our data transmission needs. In order to ensure that we understand the equipment status and the connect status at the edge of the network, we need to set up data collection devices like the aggregators. At the same time, some situations that require low latency and fast response can be controlled and responded by the data collection device. It is best to connect the data collection device to a trusted network and use the cloud or other devices to monitor it to ensure that it connects. The connection and the transmission are stable. Communication architecture diagram of the household smart meters. Smart appliances are connected to the smart meters through the home network, allowing users to grasp the power consumption and the various conditions of each appliance. The meter is connected to the regional data concentrator, where the simple control and the calculation can be carried out. And the data can be transferred to the control center, the meter's data management system. The evolution history of mobile communication technologies for your reference. Let's say the 1G all the way to the 5G. The United States Wireless Industry Association pointed out that the 1G only has a 2.4 kbps transmission speed, but it also has taken a very, very big step forward, breaking through the past fixed point line mobile phones, and it takes the voice service to the with the mobility. The 2G rate is between 56K to 115 kbps, realizing the digitization of voice communication and transmitting the text through the small screen on the mobile phone, opening the era of the SMS. The 3G standard was officially announced in 2000 and has a rate of more than 300 kbps, allowing users to browse websites and enjoy the streaming music. Nowadays, we have the stable speed brought by the 4G. It's considered to be the driving force of the app economic, and also drives the development of the social websites. The 5G communication technologies, the 5G generation, the 5th generation mobile networks, or the 5th generation wireless system, abbreviated as 5G, refer to the 5th generation mobile communication technology, which is an extension of the 4G system. After 40 years development, the mobile communication finally reached to the current 5G. Innovations in network communication technology appear on average every 10 years. New technology, new network technology communication have brought people a lot of changes in life in the industry. And then we can see that the difference between 4G and 5G, they are very, very big improvement in the bandwidth, in the delay, in the rates, and also in the coverage. There are several characteristics, several special features for the 5G internets. They have the 5G will be faster, smarter, and more power efficiency than 4G, making it easier to use with a variety of new wireless devices. 5G will make smartphones faster, give birth to the smart public facility and the smart residential devices, and extend the standby time of the wearable devices. We at least know that the speed of the 5G network will increase tenfold and compared to the network speed, ultra-low latency, and will be considered will be the cornerstone of innovative 5G network applications. And the 5G communication devices are characterized by the high data transmission speed, reduced data reading delay, and cost reduction, energy saving, increase the device capacity and the connection to the devices. The frequency spectrum is flexible, and the optimized millimeter wave spectrum can provide 10 gigabits per second throughput. It's 10 times of the current 4G communication. Ultra-low latency. 5G can reduce the transmission delay to 1 millisecond by changing the confirmation process. Network slicing meets the specific application requirements, support general mobile customers and the corporate private traffic, and provides a secure space for storing, sharing, and analyzing data. Well, the most important feature, the energy efficiency. 5G can reduce grid power consumption when transmission is not in progress, reduce the operating costs. So here's the satellite system development towards integration with the ground mobile communication system. The illustration is for your reference. You can see that the Wi-Fi, the LTE, the 5G, and the satellite is all integrated, and they are all coexisting. The infrastructure for the smart grid is gradually progressing. In order to achieve the goal of energy saving and promote the transmission of low carbon energy, advanced metering infrastructure, the so-called AMI, is one of the important tasks. The small power grid is a large-scale comprehensive project that requires a lot of time and effort. The infrastructure of smart meters is composed of smart meters, communication systems, and the meter information management system. It is the most important construction for achieving the goals of smart grids. Currently, Taiwan's high voltage users and high power users have been updated to the smart meters. The next step is gradually replace the building, the shopping malls, and even the general household users. It is estimated that by the year of 110, there will be 1 million low voltage users with the electricity prices, which can reduce the peak load and the equivalent of the saving the nuclear plant 40% of the power of the units. Let's see the home energy management system. The home power consumption detection and data transmission to the data collectors and the management system. The electricity consumption data of each smart home appliances is displayed on the apps and the web pages. After the control center obtains the energy usage data of the household users, it can analyze and make the decision based on the electricity usage data. Smart meter attack scenario. User alter the electricity consumption of the meter to avoid the bills and change the electricity consumption to the lower numeric. external malicious personnel increase the power consumption, causing the user to incur unnecessary expenses. Attack method 1, route A attacks from the power company side 2, route B attacks from the household, the EnMS side. According to the FBI 2017 report, hackers continue to try to attack nuclear power plants and the energy equipment companies, as well as the factories in the United States and other countries. The frequency number of the attacks is clearly increased. Smart meters and the hypothetical victims of the current cyber attacks. Well, the future home energy management scenario here, we can see that the EnMS works for the data collection, for the decision-making assistance, and of course, the send out the orders to execute it, and for the devices. So you can see that we have the solar plates here. We monitor the power generation, the lighting, the intelligent appliances, the computer and the mobile phone, the storage, and the vehicle, the electric vehicle, and of course, the EnMS communicate with the power operators via the AMI. Adapting predictive energy models adjust the energy consumption of the building through changes in energy prices, weather changes, and information inside the building. Utilize the structure of the building itself or its own solar power generation to reduce the summer and the winter loads. Based on the past data, the model learns, compares, and adjusts itself with the parameters. This is the visualization of energy consumption. You can see all the colors and for the annual energy display here. This is a very, very good example for the data visualization. And let's talk about the predictive maintenance of the data collection. Well, you can see that we have to make the operation and the maintenance of the equipment. So in the traditional time, we just fix it when it really fails. And for the better preparation, we may have the periodic maintenance. Somehow, with the AI introduced, we can have the predictive maintenance. You can see the charts here. We monitor the equipment of the condition of the equipment. So, like here, we will have the periodic maintenance. Somehow, if we make the maintenance here, and the condition is going low, so the sign is happening here, the system is failing here. So if you are having the data collection and make the computation, you can see the status is going down here. So you can have the predictive maintenance during this time. And somehow, well, the worst scenario, you have to fix it, repair them after the disaster has happened. You have to shut everything down, and it will cost you a lot. So the data analysis help us to do the preventive and the predictive maintenance. Take the solar power as an example. We just collect the historical power generation data of the various inverters and different sites in the past. So compare the current data. It can be found manually from the graphics and the machine learning models to understand whether there will be some abnormal signs in the operation conditions. And the maintenance personnel will be sent to the sites to check on the status. And we will, of course, collect and record and understand the power generation equipment problems, and classify and try to analyze the possible causes. And we will recursively monitor the status of the existing equipment to see if there are any same problem just happening. So you can see that that will be a very, very optimized circle. The data collection, the modeling, find out the problems, and optimizing everything, and try to make it better and better with the data analysis. This is the example of the system status from the solar power curve. You can see that on the very first one, it's the smooth curve, the normal power generation in the sunny weather. This one, you can see the seesaws here, the sawtooth curve. Well, it might be the cloudy, rainy weather. And this one, well, that's a very, very big break here. The curve break, communication problem, or the system failure is happening. And somehow, on the very last one, the shading of the roof or other reason, there will be a downward curve. So there might be the trees or the cloud coming up. Things will happen and observed like this. And the very, very important part is the data visualization. Sometimes, most of the time, we will have the basic mathematics display, with a function, with a linear algebra, with algorithms. Or we can have the graphical canvas, like the web pages, computational graphics. And we will have the engineering algorithms, like the statistical algorithm or common layout algorithms. And we will do the analyze information, like the data cleaning, statistics, and the data modeling. And somehow, with the visualization, we have to have the beauty of it, the design of the aesthetics. We have the design principle, the judgment, the color, and interactive connectivity, and the cognition. And of course, we will have the visualization basis, like the visual coding, visual analysis, and the graphical interaction. And finally, we have the visualization solutions, you have to use the charts or the common business visualization scenarios, like the bar, the pie charts, and everything. Take this one for the example. Use the data visualization to increase the processing efficiency. The amount of information that the human use visually to obtain the excess other organs. So the visualization can explain the process and more complex information to enhance the memory. So here are some examples of the data and the visualization patterns. And the utilities can effectively use the data. The maintenance team of the energy management system can judge the situation and deal with it properly based on the historical condition and the visual information. Frequently, a curve problem can be marked and handed over to the automatic system or data analysis team for further analysis and processing, establishing the appropriate judgment and the data processing models, and continuously optimizing the judgment and the models. This control judgment can be deployed at different network levels, and the data analysis also helps the company make business decisions better, help the company reduce the expenses and maximize their revenue. These are the examples for the visual charts help the business division. You can see the bar here, the pie charts here, and sometimes we will call it the business intelligence because it's really easier and friendlier for the people with sales or with the finance side to read and to understand. Well, finally, let's take a look at the conclusion today. The EnMS have different uses in different fields. Due to the development and environmental awareness and smart energy, it has gradually changed from the electric power companies, manufacturing industry, and buildings to the management system commonly available in ordinary household. The current infrastructures, such as smart meters, is not complete yet. So a complete smart grid takes time. The development of renewable energy and electric vehicles have been promoted in the process of intelligence. Many power companies are already trying to apply 5G networks, blockchain, and AI to the power grid, and promote different applications such as tradable power platforms. A large amount of data analysis is very, very helpful for business decision making and help the development of artificial intelligence in the energy field in the future. Thank you very much.